weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois, Urbana-Champaign, and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world. I'm your host, Maddie Stover, a doctoral student in physics here at the University of Illinois, Urbana-Champaign.
And I'm Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois. On Saturday, January 24th, into Sunday, January 25th, a powerful winter storm swept across the U.S., impacting areas from Texas and New Mexico all the way to Boston and New England, including here in central Illinois. It brought heavy snow to some areas, freezing rain and sleet to others, and extreme cold temperatures both before, during, and after the storm.
Let's talk about temperatures because it is freezing out there. 7 in Champaign, 7 in Mattoon, 8 degrees down in Effingham. But the bigger thing right now is the winds.
I will say the snow has started to slow down, but the wind sure hasn't. So it's blowing the fresh snow all over the place. Now,
this winter storm was massive, still is massive. It started way off to the west. It brought some snow to New Mexico. Now it's up here across the northeast delivering.
The National Weather Service snow depth reports include 4.5 inches in Paxton and Mahomet, 5 inches in Rantoul, and 6.5 inches in Urbana.
The weekend of January 24th and 25th also saw the most flight cancellations since the COVID-19 pandemic due to the storm. As of Tuesday, at least 35 weather-related deaths were reported, and at one point, more than 1 million people lost power. Let's bring another voice into the conversation. Andrew Pritchard is a meteorologist with Nutrient Ag Solutions, and he also kept listeners at Illinois Public Media up to speed on the storm. Andrew, thank you for joining us.
Always a pleasure.
So, Andrew, can you tell us a little bit more about some of the impacts across the country we're seeing from the storm?
Well, of course, here in central Illinois, we've got a nice snowfall out there, around 6 or 7 inches in Champaign County, higher totals across south central and southern Illinois. And it's because of the very bitterly cold Arctic air we have in place. It's a light, powdery snow. So the impacts here, of course, we've got some e-learning days with the bitterly cold temperatures. Schools are out. We've seen businesses closed, kind of your typical winter storm experience. But as you head a little bit further south, we did see some heavy snowfall occur in areas that don't see it quite as often across the southern plains, portions of Oklahoma and Texas into Arkansas, where it's a little bit more of a big deal when they get these snows. They don't quite have the infrastructure there when I say that, I mean a fleet of snowplows, for example, to get out there and clear the roads. So it can be a bit more of a shutdown situation when they get the snow there. But as Jeff mentioned, you go a little bit further south and we had this precipitation falling as rain because there was still that layer of warm air aloft, but below freezing temperatures at the ground. So this rain was freezing on contact to trees and power lines and roads. And this is where you have more of a winter weather disaster now, where there's been major tree branches, collapsing and falling. We've seen power lines falling both because of the weight of the ice and because trees are falling on them. So you end up with widespread power outages and hazardous travel across the area. And when you factor in the extremely cold temperatures here, you can imagine having a lot of people without power, without heat, and then the temperature outside falling down into the single digits or colder is really a dangerous situation. So kind of a typical winter storm for us here in central Illinois, but some of these extreme impacts, a little bit further south have really been disastrous.
And I've seen some of the pictures, like out of Oxford, Mississippi, home of the University of Mississippi, over toward Nashville, Tennessee, of just trees down everywhere. So it's not just, a couple power lines went down, but maybe, a power line's down only serving 5 people, and you have hundreds or thousands of these down lines, and it just is going to take time to get people out there. Some of the roads impassable with down trees. And again, as you go on into 24 and more hours without power, certainly a risk of hypothermia and those cold weather ailments begins to set in. But also, for homes, for businesses, the risk of frozen and bursting pipes as well. And that's a whole other disaster. Where now, of course, is a pipe full of water. It freezes. Well, ice is less dense than water, so it expands and it can burst the pipe. And then you end up with a flooding situation inside your house on top of everything else you're dealing with. And of course, that water damage can be absolutely catastrophic if any of you have ever had to deal with that in your own homes.
What were the conditions that set up this powerful storm?
Yeah, this storm wasn't really all that unusual in how it developed. You had an upper level trough moving off the Pacific across California and the desert Southwest, which is a very common occurrence. And in response to that, an area of low pressure formed east of the Rocky Mountains across the southern high plains of New Mexico, western Texas down toward the Gulf Coast. Now, this storm wasn't extremely strong in terms of its low pressure. So meteorologists use units of millibars to measure pressure. Average pressure is around 1013 or so at sea level. A strong high pressure system might be 1040 or 1050 millibars. And when a low pressure system gets down below 1,000, that's a pretty strong low. And then thinking back, stronger tropical cyclones, you'll get pressures down into the low 900s. But these types of winter storms never get that strong here in the United States. But ahead of that storm, a big blast of Arctic air came down from Canada. Storm again hit Saturday into Sunday. And on Friday, last Friday, if you think about how cold it was, all this cold air came southward. And so as this low pressure system developed down across Texas, counterclockwise flow around that area of low pressure brought a lot of warm and moist air northward out of the Gulf of Mexico. And as this warm air encountered the very cold air at the surface, it was forced to go over that cold air mass. And again, as air goes up, what happens? If we have sufficient moisture, we form clouds and we form precipitation. And so that led to areas of rain down along the Gulf Coast, even a tornado in the Florida Panhandle on Sunday. And then a very expansive area of ice, that is sleet and freezing rain, that impacted areas from northern Louisiana across a lot of the Mid-South through Tennessee, and then again into the Mid-Atlantic and the Piedmont there. And then farther north, where the entire atmosphere was below freezing, we saw an extensive area of snowfall. Again, even El Paso, Texas, on the Mexican border reported snow, all the way up across parts of Texas, Oklahoma, across a lot of Illinois into the Midwest, and eventually into the Northeast.
So, Jeff, before we hopped on this call, you were talking a little bit about the difficulties in forecasting this event. You were saying that for your weather systems class you teach, that your forecast was changing pretty rapidly. Can you kind of walk us through the forecasting of this event the week leading up to it?
Right, yeah. Even beyond a week out, there was a pretty good signal in our medium range models that there would be a fairly major winter storm bringing a lot of wintry precipitation, ice, and snow. But a lot of the models were suggesting that was really going to stay across the southern United States, maybe up to the Ohio Valley, and that here in Illinois, we would kind of be north of some of the worst of that and maybe just get a couple flurries, if anything. And I told first day of classes was last Tuesday here at U of I. And I told my students, I said, look, yeah, big storm across the south. Doesn't look like we have much to worry about here. But then kind of Tuesday or Wednesday before the storm, again, the storm hit on Saturday and Sunday, those models really began to shift that storm track and the track of the heaviest snow on northward into a lot of the Midwest here, central Illinois. Indianapolis got 10 inches of snow. Columbus got a foot. Detroit got several inches of snow. Chicago got about as much snow as we did. They got, again, another lake effect snow event up there. And so by Wednesday, when I saw my 100 level introductory course, I said, well, I think we'll say 2 to 4, but I'm highly uncertain on 2 to 4 inches because we're still several days out from the storm. And I really don't like going numbers for snowfall that far out because it can be quite fickle depending on several different factors. And then Thursday morning, in my graduate weather systems class, I said 2 to 5 plus. And then finally, Thursday afternoon, I upped it to 3 to 7 for my undergraduate forecasting class and then stuck it there throughout the duration of the storm. And again, the upper end of that is what ended up verifying. Now, so as a result of that northward shift, a lot of areas that weren't expecting snow initially got snow. But again, this was still well forecast a few days in advance, so people were able to prepare for it and go buy their bread, milk, and toilet paper out at the grocery store to make, I don't know, a toilet paper sandwich or what you do with that during a winter storm. I don't really understand. Um, but anyway, also some of the areas that were initially expecting to see a lot of ice, like parts of Alabama, for example, they really only got rain down there as a result of the slightly warmer and farther north solution. And again, that area of ice kind of shifted north up toward Tennessee. And again, parts of the Carolinas and Virginia as well. A lot of ice with that due to a phenomenon called cold air damming, where the cold air kind of gets stuck or trapped east of the Appalachian Mountains there along parts of the East Coast.
And Andrew, so we might be kind of getting close to the time of year where some of the farmers are starting to plan for a growing season. Are we going to see any ag impacts from this winter storm?
The ag impact right now is a lot of farmers that are hoping to see moisture. And so snow is good because it is, water. It's frozen water there on the crops, but it doesn't provide a whole lot when you think about how big this drought has become going back to the end of the summer, going through the fall, and then into the winter time here. So what we would really like to see is more of these big areas of low pressure rolling across the country and bringing either big doses of snow that we can eventually melt and try and absorb into the soil, or what'll probably be more likely is getting into the later part of the spring and getting showers and thunderstorms to move through here as we're getting kind of late into the winter season. But right now, there's a lot of people from Illinois all the way across the Corn Belt who dealt with a really dry fall. And while we were able to cash in on some of this snow, there's a lot of the upper Midwest and, central and northern plains that did not get this and have been really just getting very light doses of snowfall. So it's kind of the ag impact is it's moisture, but we would like to see a lot more of this kind of thing during the winter season, especially after a fall with such significant drought.
If you're just tuning in, you're listening to Weather Realness, the weekly podcast about climate and weather. We're talking about this January winter storm with Andrew Pritchard, meteorologist at Nutrient Ag Solutions, and Jeff Frame, professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois, Urbana-Champaign. So, Jeff, how long can we expect the extreme cold to last here in central Illinois?
So I think the worst of the cold comes through this week. And then kind of, it's still going to be chilly, but I think more seasonal cold as we go on into the very end of January, into the first week of February. I'll look at some of the long range guidance and forecasts from the Climate Prediction Center. Indicate a pretty good chance of below average temperatures persisting across the Great Lakes into the Northeast, with above average temperatures likely across most of the West. Down across Texas and kind of this battle zone in between. But I think still we average below normal into early February. But along with this, I'm not really seeing any big winter storms on the horizon. Unfortunate for folks hoping to break the drought. Looks like, a couple nuisance snowfalls, kind of those 1 to 3 inches might be possible. But doesn't look like any big storms, at least here in Illinois. Now, the weekend of the 31st into the 1st, there is a chance of a more significant East Coast winter storm, but that doesn't look to directly affect us here in Illinois.
I understand that salt doesn't work to melt the ice on roads in extreme cold. Jeff, why is that?
Yeah, so the reason salt works to begin with to melt ice and snow is that if you take water and you freeze it into ice, what the water molecules have to do is assemble into this lattice crystal structure and get very well organized. You can kind of think of it, like some kind of a group of soldiers or military marching in formation, right? They're very orderly in a very regular fashion. Whereas liquid water molecules, it's a lot more like an ordinary crowd of people. They're not really organized in any way, but they're still relatively close together. And so when you put salt into water, what that does is that the salt molecules actually disrupt the water, forming that crystal structure that you need for ice. And all snow is a bunch of microscopic ice crystals anyway, so it's still ice, is what snow is. And so what salt molecules do is they disrupt the formation of this crystal lattice you need to freeze the water. And so the water is able to stay liquid at colder temperatures. But it can get so cold that begins not to matter as much. So, for example, the Arctic Ocean up at the North Pole, every winter that freezes over. Or one thing we talk about with impacts of climate change is melting Arctic sea ice. Well, it gets so cold up there, the ocean actually freezes. And so the same thing happens here, right? It just gets so cold that the salty substance they put on the ground or on the roads, it just does not work as well, or you have to put down a lot more of it. And I do understand that IDOT and some of the other agencies do have some more expensive ice melt that can work at lower temperatures. But again, that really does kind of drive up the cost of some of that. As long as these cold temperatures linger here, certainly, hopefully into the weekend, we should be getting temperatures warm enough that we'll start being able to melt some of this off the roadways, at least.
Interesting. And you talked a little bit about climate. I'm curious, what is kind of the climate changes effect on the severe winter storms? And have there been any studies to attribute this storm to climate change?
It's way too early to do a study to attribute this particular storm to climate change. What we have seen in the past is that climate change, right, kind of, this global warming effect, making summer heat waves worse and more frequent, but making winter cold waves not as cold and a little bit less frequent. So that's in terms of temperature. In terms of the storms themselves, it's very hard to get at that because, again, the storm only lasted a couple of days. One thing we have seen is, maybe a little bit more precipitation falling out of these things. But again, it didn't cause this storm or do anything like that. But in terms of snow, it's tricky because we're seeing, more precipitation from some of these events. Maybe 5 to 10% more precipitation. But we're also seeing, slightly warmer temperatures. If you have a 30-degree snowstorm, well, now all of a sudden it's at 33 in rain, for example. Or, if it's colder, well, instead of, 6 inches of snow, we got 7. I wouldn't expect a big climate impact with this because, again, these are individual weather events. Whereas climate, of course, is the average of the weather, or I like to say, climate is what you expect. Weather is what you get. So, for example, we had a big snowstorm on January 24th and 25th, but we're not going to see that on, January 28th, for example. Although, if you would have asked me a month ago, I would have said, kind of equal chances either of those days. It's late January in Illinois. We get this kind of stuff this time of year. But will it snow on the 4th of July? Absolutely not.
So, to close out the show, we have a couple of listener questions. So, starting with you, Andrew, Dan from Urbana asks, alluding to a storm about 2 weeks ago when this airs, what is a snow squall?
That's a great question. And you can kind of think of the difference here. Think about the winter storm we just experienced. It was, 18 to 30 hours of continuous snow across central Illinois. And that's what you typically get with that area of low pressure moving across the country, bringing a big snow shield that's going to last for the better part of a day or two and give you that big snowfall. Now, what we've seen over the last couple of months, I mean, we've seen this on multiple occasions here, but we just saw it in mid-January with these clipper systems that come down in these Arctic fronts. These snow squalls are a little bit more like the showers and thunderstorms that we get during the spring and the summertime. And that being kind of a compact little, it's sometimes you can even see the puffy cumulus cloud out there. And so it's these little isolated squalls that are producing a big downpour of snow. So instead of a heavy downpour of rain or hail or something like that, it's extremely heavy snowfall, and you can have some blustery winds with that as well, similar to your showers and thunderstorms. And so these produce very short-term snowfalls and often lighter snow amounts. But the reason that they are making news now is because they're extremely dangerous to motorists, especially. And so I know everyone in Champaign-Urbana, their phone was going off as if it was the end of the world or, a tornado warning with that wireless emergency alert, and kind of wondering what's going on and maybe even in some cases joking about it in town. But these are deadly when you're driving down the interstate here and you're in clear conditions, maybe even the sun is shining, and then all of a sudden you're in a blizzard. Visibility is zero and it's heavy snowfall, maybe some strong winds there. And so you get that quick reduction in visibility and driving conditions. And there have been multiple instances of big pileups. It causes maybe an accident up the road, and then everyone else is unaware of what's going on. They're still traveling 60, 65 miles an hour, and then, suddenly crash into that accident. You get a chain reaction. So they kind of said we need to do something about this, and the best course was to warn everyone on their phones who's going to be in that area that there's a snow squall ahead. You're going to have a sudden reduction in visibility, some heavy snow and some blustery winds, and pull over, let it pass, and it will do so rather quickly, 10 to 15 minutes. But like we saw in mid-January, this can delay travel. I was trying to board a flight in Chicago and it shut everything down for a while. And then that same squall went right down Interstate 57 into Champaign County and caused some trouble down here. So snow squall, heavy burst of very, intense snow and blustery winds, and a reduction in visibility. Very short-term thing compared to a typical snowstorm, which is your longer lasting snow event.
Right, and it can ice up or flash freeze the roadways too, because the first snowflakes, right, it might be relatively warm, might melt, and then you get more heavy snow on top of it, temperatures drop, and so then that layer of water freezes, and then you get snow on top of that, and so you can get these sudden flash freeze ups of the interstates. I remember when I was in graduate school in Pennsylvania, there was a big accident on I-80 from one of these snow squalls. It was so bad it actually melted the asphalt, and a couple people had to be identified from dental records. The fire was so bad and so hot in that. So again, certainly if you're traveling by car especially, yeah, you want to take these snow squall warnings very, very seriously.
And the best course of action, say if you were already on the highway, would you be just to pull over and wait for it to pass?
Yeah, pull over, get off the interstate if you can, but if you can't, obviously, the shoulder is still better than traveling along at any rate of speed when you can't see.
Great time for a pit stop.
So Jeff Casey from Urbana asks, or is curious, so it's expected that the record for the longest kick will be broken in Denver this year. What is it about Denver that allows for kicking a football so much further?
Okay, so we're talking about the NFL here, going back to our weather and football episode from December. And Denver is known as the Mile High City, so it's at about 5,280 feet above sea level. To put that in perspective, here in Champaign-Urbana, we're at about 600 feet, so very close to sea level. And so one thing about air pressure and air density is they decrease with height in the atmosphere, and they do that very rapidly. This is why, for example, airplanes, big jets, are pressurized because where they fly around about 30,000 feet high, the air density is only about 30% of that down here at lower elevations, which would mean that every breath you would take, you're only getting about 30% of the oxygen that you otherwise would. And of course, that has a negative impact on the human body. That's why people bring oxygen tanks as they climb Mount Everest. Now, Denver is not that extreme, right? Only being a mile, not 6 miles high. But still, air density there is only about 85% of what it is here at lower elevations. So that means there's a lot less air resistance to something kicked or thrown through the air. So that's why a lot of times some of your longer field goal kicks occur in Denver. Of course, not during the snowstorm there at the end of the AFC Championship game. Pretty slick footing for the kickers at the end of that one. I came in from shoveling. I saw that. I'm like, well, I didn't even know it was supposed to snow in Denver today, but here we are. And also, Same thing happens with the Colorado Rockies baseball team playing there in Coors Field, that they just hit their baseball players are able to hit the ball a little bit farther up there at elevation in Denver. And then kind of another athletic effect of that is, again, you're only getting 85% of the oxygen that you're used to. So it can take a while to acclimate to higher elevations, particularly if you were to leave here in Champaign and say go hiking in the mountains up at 10,000 feet. Well, now it's maybe only you're getting 70% of the air there that you're used to. So maybe take a couple days, acclimate to the altitude before you try the big hike if you go out to Colorado or the Rocky Mountains.
All right, Andrew and Jeff, thank you for joining us.
Always a pleasure. Thank you, Maddie.
Likewise, happy to be here.
Andrew Pritchard is a meteorologist at Nutrient Ag Solutions, and Jeff Frame is a professor in the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois. For those just tuning in, you're listening to Weather Realness, the podcast about weather and climate. Have a weather or climate question you want us to tackle? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu. Coming up next, we're talking more about winter weather.